So the past couple of days, we have been learning our multiplication facts and really practicing some strategies to figure those facts out. We've done our zeros, we've done our ones, we've done our twos. We learned how we can use our twos to help us with our fours. We've done our fives, and we know how to use our fives to help us with our tens. Today we're going to be talking about a harder multiplication fact. So far we've been doing pretty easy skip counts. Ava, I told you to put that up yet. Ava, put it up, please. Nope, not in the bin because it's not stapled. So we're going to learn a trick to make our nines easier. I like nines to be easy, not hard. I need this to be your title. How could I solve the problem 9 times 7? That's your title on the next blank page, please. Alright, so we do know some multiplication strategies already that we can use with any problem. If someone gave you paper or a whiteboard and said, okay, solve 9 times 7, what could you do to help you figure that out? What could be a strategy that you use? Paxton?
9 groups.
Okay, would that look, can you describe what that would look like? 9 groups of 7, what would that look like?
9 rows of 7.
Okay. I'm writing, that means you are writing. Paxton said I could make an array. I could make 9 rows of 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. Hey Paxton, this seems like it's going to be a lot of dots. Do you think I could use a fast array? Yeah, I'm going to draw a fast array, but Paxton's right. You could draw a full array. Got 1, 2. Marley got this array down?
Yeah.
That doesn't look like 9 groups of 7. It looks like 9 groups of 4. What could be another strategy? An array would be awesome. But what would be another strategy you could use to help you figure that out? Marley?
You could do, so I'm kind of adding on to what Paxton did, but, you could count by 7s, and you can use your 5, and then when you have your 5, you could add 2.
Love that. So can you tell me what my addition equation would be if I was adding 7s?
You could,
I'm probably going to start with 7.
yeah.
Then what?
7, and then 9?
Am I going to add 7 and 9 together?
No.
Read this to
7
me.
plus 2.
Read this to me again in English.
9, no, 9 groups of 7.
Can someone help out Marley? She wants to do 9 groups of 7 as an addition equation, but she's kind of getting stuck on what that might look like. Maverick, you want to help her out?
7 groups of plus 7 plus 7 plus 7 plus 7 plus 7 plus 7.
1, 2, 3, 4, 5, 6, 7.
Plus 7 plus 7.
How many 7s you got?
9.
9 groups of 7 would look like that. Ooh, 7 plus 7 plus 7 plus 7 plus 7 plus 7 plus 7. Write that down. Are there any other strategies we've learned? Nathan?
Counting groups.
Okay, can you describe what that might look like?
So what I meant was that you take simple 7. Simple 7 is 14. Put that into the group, and that would be 14. Put another 7 into a group, that would be 12 or 14. And just times all those together, and then your final answer would be 2 plus 14 plus 14 plus 14.
But we're still using addition for that strategy.
So it'll be 14 plus 14 plus 14 plus 14 plus 14 plus 14.
But we're using this equation.
Yes.
Okay. Is there a different way to do it other than addition? Are you grouping them like what Mason was saying? Avery, what you think?
You could draw nine circles.
9 circles.
And put 7 in them. And then put 7 in each one.
All right. That looks like 9 groups of 7.
That's just what I was thinking.
Yep. These are all great representations. Saw a lot of Me Too signals on that also. Nice. This still, even though those are all correct, they're a lot of work, right? Even though we can do it, we can add up all those 7s, we can count up all those groups, that's still a lot of work. Archer, what are your thoughts?
Can we switch? So I was thinking we could use Paxton's,
Mm-hmm.
but we could switch it around.
What is that called when we switch it around?
I keep forgetting.
Ooh, it does have a name. So, Archer, you're saying instead of thinking about it as 9 groups of 7, you want to think about it as 7 groups of 9? Definitely could. Callie, what's that called?
Property.
The commutative property. A lot of you had that in your brain. This is a great strategy. And if you're thinking about it as 7 groups of 9, that's a little less circles you got to draw. We're writing this down, right? If I'm writing, you're writing things. You can think about that to help you figure it out. Now, if I had to make 9 goodie bags with 7 in each, could I make 7 goodie bags with 9 in each? No, that wouldn't be fair. That wouldn't work. But if I just need to figure out how many total, I can flip it around. That is fine. Yep. Yeah, we've got a lot of great strategies so far. A lot of great strategies. Today we're going to look at another one because my 9s are hard. But my 9s are really close to something that's easy for me. My 9s are really close to my 10s. I want you to write this question. It can be a subtitle or it can be a title on a new page if you need to turn the page. How can I use my 10s to help me solve my 9s? So you can write that on a new page or you can write it as a subtitle. All right, Mason, I'm ready to hear your thoughts, friend.
So, 10, so we know that 10 or 3 times 10 is 30.
Mm-hmm.
So, I can use, so I count my 10s.
Mm-hmm.
So 10, 40, 30, 40. But the 9 is right behind the 10, so I just take 1 off. That would be 39.
Brilliant. You're really close. You're almost there. We're going to use that example that Mason just gave us, and we're going to write it down first, and then we're going to look at it with our counter. So I want you to write this down. We know that what Mason said, he said 10 times 3. He really said 3 times 10, but I'm going to put the 10 first because when I say it, I say this as 10 groups of 3. When I read 10 times 3, I'm really reading 10 groups of 3. Brogan, do you have a question?
Yes.
Yes, what's up, friend?
Don't you always say, put the bigger number,
Absolutely not. I've never said that, ever.
the smaller number first?
I've never said that either.
Still do it.
I believe I have always said make your equation match your picture, but I have never said anything about putting a bigger number, smaller number in any order. And we're trying to figure out 9 times 3, which we know really means 9 groups of 3. Mason's helping us. You're starting off at 10 groups of 3, but we're really trying to get to 9 groups of 3. We're really trying to solve this, but we're going to use our 10s to help us get there. Connor, what are your thoughts, friend?
One of my thoughts was usually sometimes I help myself while using 9s. Like if it's a ton of 9s, like this time. I did the same where instead of putting in 9s, I just put 10s, and this. If we go back to our other one with all the 9s, it's just a 10 plus 10 plus 10 plus 10 plus 10 plus 10. But since it's the same 9s, just get rid of 7 after doing all that.
Yep.
So it's just going to be 16.
It's really almost the same strategy, isn't it? All right. Once you have that written down, just move your notebook to the side. Don't close it. And I want you to create a 10 by 3 array. 10 groups of 3 array. I don't care which color you use, but keep them all the same color. So they either all need to be red or they all need to be yellow. Mason, can you go grab a math kit? You're going to work by yourself, so just so you're not spinning around. All right. In order to do this, we need to know where our groups are. So we're going to karate chop our groups. Now you're sharing, so please don't karate chop each other's hands. You can maybe touch it. But we're going to count our groups. Ready? We're counting the groups. 1, 2, you counting with me? 3, 4, 5, 6, 7, 8, 9, 10. We should have done 10 karate chops now. Those are our 10 groups. But we need 9 groups of 3. How would I change my picture, my array, to be 9 groups of 3? Yep, you got it. Take away 1 group of 3. If this is my group of 3, and I take it away, move a group of 3 out of the way, how many groups of 3 do I have now? Count them. 1, 2, 3, 4, 5, 6, 7, 8, 9.
10.
Do I have 9 groups of 3 now? I should have 10 because I took 1 away. Now, could I count them all up now? Yeah, but that seems like a lot of work. Put that group of 3 back. We're back at 10 groups of 3. What is 10 groups of 3 worth? That's pretty easy for me to figure out. What is 10 groups of 3 worth, Julian? 30. And then, Julian, what happened to my 30? What did I do? What did we just do on my array? Mason, what did I just do?
You took away 3 of them, and that leaves you with 9.
Took away 1 group of 3. So now I've got 30 minus 3. What is 30 minus 3? Count backwards if you need to. What is 30 minus 3? All right, you figure it out? Still thinking? I see some fingers moving. That's awesome. Ava, you figured it out?
It's 28.
Let's try it again. Ready? 30.
29.
29. You have 2 fingers up. Remember, my starting number doesn't count, so I have to make a fist. 30. 29.
28. 27.
27. So when I took away that group of 3, Julian, when I took away that group of 3, how many do I have now?
27.
How many do I have now?
27.
27. So what is 9 times 3?
27.
27. Go ahead and write these equations in your notebook. We're going to do another one with counters, so don't put your counters up. But add those equations to your notebook. You don't have to draw the array. Just add these equations.
So get out.
So we are going to try and figure out 9 times 6. I am not good at skip counting by 9s. And I'm not good at skip counting by 6s. But I do know that 9 times 6 is close to 10 times 6. So let's build 10 times 6 as an array. Go ahead and build that. You're definitely going to have to use all the counters you've got, and you still might not have enough. That's okay. Go ahead and build 10 times 6. All right, by now, Colby, you should have made 10 groups of 6. You got something like that? Great. We've got 10 groups of 6. But we actually want 9 groups of 6. So how am I going to get from 10 groups of 6 to 9 groups of 6? So if you could please stop messing with your counters. Let's think about this question. You just made something that looks like 10 groups of 6, which is a lot. But you actually want 9 groups of 6. So how are you going to do that? That's 10 groups of 6. But I want 9 groups of 6. Ava, what do you think I could do?
You could chop it up.
How am I going to chop it up?
You do it by rows.
Okay. And how is that going to help me get to 9 groups of 6?
It will help you because you can skip count.
Okay, but I already told you I'm not good at skip counting by 6s. Are you good at skip counting by 6s?
I'm gonna 6.
How could I get from 10 groups of 6 to 9 groups of 6? Now, what do you think I could do?
Take away 6.
Take away 1 group of 6. If I take away 1 group of 6, do I have 9 groups of 6 now?
No.
Oh. Yeah, maybe. Yes.
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 I'm going to take away this group. There's one of my groups. Right, Ava? I'm going to get rid of it. And now how many do I have? How many groups do I have?
You got 7. 5.
Let's count my groups. Ready?
1, 2, 3, 4, 5, 6, 7, 8, 9.
I have 9 groups of 6. Get your pencil. I want to write down in math language what you just did. Get your pencil. I want you to write down in math language what you just did. You don't need to draw the array. We started with 10 groups of 6. Write that down. All right, we're writing that down. What did we do next? Emma, what did I do next?
You took away 1.
I took away 1 group of 6. I took away, that's subtraction, 1 group of 6. Do I know how to write 1 group of 6 in math language?
1 times 6.
I am going to put that in parentheses because that's a little group. It needs to stay together.
It's by itself.
Mhm.
Nothing else.
And when I did that, what did I get left with? What was the equation I was left with? I started with 10 groups of 6. And I took away 1 group of 6. And now I've got what, Jordan?
9 groups.
9 groups of 6.